This is the project presentation for automated metadata tagging and content summarization. It is Group 12, which consists of Adam Batat, Jesse Bowers, and Alejandro Suarez. Our project sponsor is John Chiasen. To summarize what the project entails, we are going to apply machine learning and artificial intelligence for contextual generation of descriptive metadata tags for educational and learning content. Metadata describes learning content, subjects, prior knowledge required, potential learning paths involved. Focus on documents and videos as well as PDF files. We will generate a table of contents. We'll generate a document or video summary. We will detect and index checklists. For example, videos and documents related to ship handling. A database and app front-end search access tagged content will also be included. The problem that we are trying to solve is the United States Navy has many training documents. When students are studying, it is hard for them to go through all the Navy documents to find the required information for studying. This project will split out the training documents into sections, create a metadata tag and a summary of the section, and insert this information into a database to different subject areas that can be easily searched for. This is a significant problem because it is important to facilitate students in learning vast amounts of material. The students and the Navy will benefit from this project by being able to more quickly learn the material, and the Navy will have more academic success. The only full existing solutions are not open source, so the Navy would incur a fee using them, and they want a no-fee solution. Also, the existing solutions do not specifically accomplish this task as a whole. The solution that we are proposing will be a system that will read a file and will start the process of reading through the file with finite parameters depending on what function it is to follow. For instance, the system can be used to analyze a document requested by a client, which will work its way through the web server and into the Linux server, in which a sequence of code will be run using Python and T5-based software to analyze and extract index lists. Consequently, they will be stored in the database, and upon demand, they will be sent back to the user and web interface for them to be able to see the extracted data. The system will be run by a web client, which is the main user that will use the program, pull requests from it, and get the results. Consequently, the request will be sent through a web server, which will communicate between the Linux server and the web client. Therefore, in the Linux server is where the program will be hosted and the code and operations will be run, which will then lead to the Oracle database, in which the information will be stored and called upon as needed. Shown is the block diagram and the state diagram for the system. We will have a web client interacting with the web server, which will interact with the Linux server. Python and T5 will be used to generate the information and metadata that will be stored in the Oracle database. Then the user can use the web client and access information in the database. This can also be seen in the state diagram.
Here we have the state diagram. So in the center of this diagram is the beginning where it says start up / idle. So the first step the user will have is one of two options. They can either search from the database and select the documents from the given database and will then go to display to the user through the output, or the user will be able to upload their documents, whether let's say a video or an image or a PDF document. It will run through the system. The system will analyze the document given, and we will process the data with GPT-2 and Python libraries. Then, with the generated information, it will then be stored into the database. The metadata tags will be stored into the database, so it can be further used to search should the user want to search for it again. And then finally, it'll output to the user the generated metadata tags and be brought back to the startup idle screen. Right here we have the video subsystem. So if the user is to input a audio file, this would be the subsystem for it. The user would first input the file as an MP3. It'll go through the system and generate a transcript. That transcript will then run through Jesse's subsystem of T5 and Python libraries to generate the metadata tags. And then finally, those metadata tags will be stored into the database where the user can then access them at any time they would like. Now, some of the video subsystem challenges would be the transcript will not be 100% accurate. This is just due to the fact that everyone talks differently, and it's going to be impossible to have a 100% accuracy rate with the transcript. Another problem is if the person has a speech impediment or an accent, it'll be harder to transcribe their voice. The transcript will not be in an organized manner like a PDF document would, so this might cause a challenge when running through the T5 or Python packages, as there's no organization there. And finally, the file must be an MP3 file, so if the file they're trying to upload is a video, they will first have to convert it, into an MP3 file before running it through the system. Here we have my complete schedule breakdown. So the first step I took was doing research on video transcribers and figure out which one I want to end up using for the final implementation. The next step would be to connect that transcriber to the web page. Then it would be to send the transcription through the Jesse part of the GPT-2 to generate the metadata tags. The next step would be to create a website and database, being able to send the metadata tags to the database. Next would be creating a user interface prototype and making it more user-friendly. Then would be to test the video transcription and testing it working through TP5. Then would be to allow users to search for metadata tags, and finally it would polish the website and do our final tests on the system.
And so we move on with Alejandro Suarez's schedule breakdown. By August 6th, I will be researching different alternatives for Tesseract. Since it is our main candidate, I will go into a bigger research, trying to make sure that's the best alternative for our project. And secondly, a month and a week after, on September 12th, I will implement a chosen image extraction, which at this point is Tesseract, and I will continue to run tests, and I will firstly implement them into the PDF and have them read from the images, PNGs or JPEGs, a certain words or in this case figures. 2 weeks after, on the 26th of September, we will implement definitely the last and most important or most efficient program. We will continue to test it. This test should include all of its possible performances, which would be words and figures, so it could transcribe them due to its internal database and provide feedback. 3 weeks after, on October 10, we will merge and implement the image extraction tool into the program. Hopefully, we will try to put together a UI or any like a UI program and try to have it display so the user can interact with them and feed the PDF documents. A couple weeks after, we will continue to test more scenarios a little bit deeper, maybe more like figures rather than images of a house. We will put some figures of a house or relative, see how long or how far can this algorithm go. And thirdly, on November the 24th, we will merge the code work completely after all the tests are done, and we will merge it with the web base code, which will have the image, audio, and text extraction. And on December the 4th, we will perform a final ET test with all of its requirements. Moving on with Jesse Bauer's schedule, we'll have that he will be implementing a Python test for metadata creation on September 12th. It is not yet defined whether it will be GPT-2 or T5, but our main thinking is that it will be an open source Python system. Secondly, whatever system is defined, on October the 10th, we will merge the document splitter with TP5 in order to achieve a list of index and a small summary after the PDF file is read. Thirdly, a couple weeks after, on October 24th, we will be test writing metadata tag, and we'll test the summary and doc location strings. So we'll be basically testing the text splitter and the text summaries. So we will try to have a doc location string where it will lead you to the page that the document has been extracted for with the summary, and so on. 2 weeks after, on November the 7th, we will test again with the writing metadata tag and then the text memory, and we'll try to link the database to the doc, to all the docs, so every single query can be recorded into the database. And 2 weeks after, we'll merge the code to work with the web-based code, which is something that goes along with all the developers. We'll try to keep our deadlines together so we can have time to fix any sort of mistakes or errors. And finally, we'll have the final EDA test on December the 5th. And here's the organizational chart for our project on the automated data tagging project. Jesse Bowers will be the team leader responsible of overseeing myself and Adam to make sure that we're doing everything correctly. And he will be the full stack developer to help me on the back end and Adam on the front end. And he's also developing the test extraction tool, which is the main source of this project. Also, we have Adam. He's the front end developer of the web server, the web encode, and he's also working on the audio extraction development of this project. And lastly, we have Alejandro Suarez, which will be working on the back end of the database, and he also will be working on the image extraction of the project.